Okay, so we're back at it again. We've got our upper link now done. The bushings are, everything is all welded. Remember, we still are going to have to disassemble everything one more time to paint everything. But the next thing we're going to start working on is our track bar mount. Now, in an off-road situation, like what my brother and I are normally used to working on, we would have ideally the longest track bar possible. And the reason for that is because anytime you think about suspension, you have to remember that everything moves in an arc, right? So if we have this hammer here, say, right, is one of our links, and it pivots on this end, as something moves, it actually moves inward or outward, depending on how it swings. And the axle is going to do essentially the same thing. So right now, as the axle travels, well, let me back up. What we've pretty much concluded that we're going to have to do is put the track bar right here. And it's going to be very short, which could cause issues if you had a lot of suspension travel. Again, the reasoning is because the shorter that arm is, as the axle travels up and down, it will draw the axle to one side or back to the other, right? This is a very low travel situation. And the other big thing is you have to remember that if you were building a car from scratch, you could design around all this stuff, right? But in this circumstance where we're using a factory fuel tank and a factory frame and all this stuff, we kind of have to work with what we're, the constraints that we have. So what we decided on is we took pretty much, it's the same bracket that we had here that we've used for our upper mount from Barnes 4-wheel drive, and we're going to install one right here. I'm going to take a minute with the flap disc and grind a slight bevel to this so that it fits on the radius of the center section here pretty well. I got to put that bolt in the opposite way before that's stuck in there forever. I got to remember to do that. But and then what we're going to do is we're going to clean up this side of the frame here. Or I'm actually going to plate over this a little bit to help reinforce the whole area. And then we have our bracket for our frame side here. This one I'm gonna have to play with and figure out what scenario is gonna work the best for it. It's supposed to be set up like this, okay? And in the last time we were out to the shop, we cut the bottom few holes off from it. It was too long. It was going to hit the axle anyways. Again, a lot of these parts are designed for off-road stuff where you're going to want the extra height to kind of reduce your separation between your link pivot points. But obviously on this, like I said, with the constraints, we're not going to need that. So I'm going to have to figure out what fits the frame best, if we need it this way or this way. We do also have part of the old bump stop down here, which I might remove, or it might be easier to just plasma cut a notch out of this to kind of trim around the old bump stop, which can just give us another place to weld to. So let's get that stuff figured out next, and get our track bar built. All right, so for the next part here, I'm going to go ahead and make our plate that we are going to plate the frame up here with. And the main reason for that is because our 90-degree bracket here, it'll give it a point of contact on the bottom of the frame, as well as up here, now along the side of the frame. Now, if you were doing this with a box frame, obviously you wouldn't have to do something like this. The frame on this is kind of an odd shape. As you can see, the top here, and then the bottom is a little different. The bottom kind of juts out. So what we're going to do is we're going to set the plate on the bottom part of the frame, and we're going to actually have to trim this little bit out here, and then We can weld along the top. I might even try to put the bend in here that matches this section of the frame. And to do that, the 1/4-inch plate here that we have, the quickest, easiest way to do this is with the plasma cutter. Now I know you're thinking, plasmas are expensive. You know, you don't have one in your garage, and that's fine. A grinder, anything really, Sawzall works great for cutting that as well. But before you think about how expensive a plasma could be, I simply have this Jegs unit here. It's a few years old now, and this thing has been flawless. I think I paid $240 for this back in the day when I bought it. It might have been $270. It's not very big, but it runs on 220. You just hook up your air hose in the back here, and kind of the real cheap generic tip. Actually, my ceramics broke here, which I got to replace soon, but this takes all the your just generic consumables that all your other eBay and Amazon plasmas take. So it's been a good buy, and it's a good way to make nice, clean, straight cuts as long as you have some sort of a guide. So what we have here is this piece of aluminum. You can see the Sharpie line here of where we're actually going to cut, and all I've done is taken the plasma, and you can see the center of the torch here, and set that up so the offset is the thickness from the ceramic to the center, so that we can just simply start the plasma and draw it down our straight guide, and that'll give us a nice straight cut. So we've got a clamp to the frame of the S-10 just as a nice work surface here, and we're going to cut this section off. Just got to remember with a plasma, you need to use a very dark face shield. Sunglasses really aren't dark enough. I know they do make glasses that are darker, that are meant for torching and plasma cutting. Those would be a good option too, but these cheap Harbor Freight face shields come with both a clear for grinding and the dark one for cutting, and they work pretty well so far. Okay, so while I have the plasma fired up, I went ahead and I cut that little notch off our frame that I showed on the lower part of the channel. And I also went around here, and now I've traced around what I think is going to be the area that the bump stop hits on this. So we're going to clamp this to the frame and now torch this section out too. Alright, so we've got our plate cut here and everything squared off. We've got this ground to where it fits pretty good. But before I do my final fit on here, I'm going to go ahead and get our plate installed. So we're going to just simply butt it up here like so and tack it in place. That might be a little spicy there. Okay, so we've got just a couple more spots I got to grind on this. I got to make this angle a little more squared off, and maybe take a little bit more out of right here, but it's looking pretty good. frame has a slight curve here, and it's very, very slight. But instead of trying to bend this in the vise or anything, I'm just going to weld a little bit, hammer it around the radius, weld a little more, and until it gets its slight contour to it. Doing it this way, you're actually using the heat from the welder to help warm your plate up so it bends easier as well. Okay, so we've got our bracket here that is now trimmed to the point that it fits really well around the contours here of the old bump stop. So it's time to tack this on the frame. Fortunately, the way this is now set up, it pretty much only fits in one spot, and it's right lined up with our axle. So I'm going to go ahead and burn this on, and then we will work on our upper mount on our axle. Okay, so now that our upper bracket is done here, now we get to do the axle side. Really nothing special with this. We just need to make sure that it's square and parallel with our frame mount, because our bushings don't have much side-to-side movement, unlike a rod end. And the other thing is we need to make sure that we have plenty of clearance to get our bolt through and our nut on and off. Obviously, we'll have to use a wrench only on this now, but that's not a big deal because we've got plenty of access on the other side. And I'm pretty much going to move this up just about as far as we can so that we get every bit of length out of our link that is possible. And I like that right there. So let's go ahead and burn it on. Okay, so now we've got our bar in place here. We have our other bushing end in its bracket now as well. The next step is we have to mark our tube to cut to weld our new bushing end. But before we do that, we've lifted the truck up and down a few times on the lift or whatever. We really need to make sure that we are at our ride height and that the axle is centered side to side under the truck. So I'm going to measure that one more time, and then we'll go ahead and make our cut, remove our bar, cut this in the bandsaw, and weld our threaded insert on. Okay, so now we're at our 6 3/8 from the outside of our rotor to our frame, both sides. And the truck is back down on the ground, front tires are on the ground, back end's back on our jack stand, where we've kind of been planning on the whole way along. So, right about there. And we do still have a few threads left here, and that gives us room to go either direction, in or out. Now, we do have it threaded in a lot further than we do out, and the reason for that is because you don't want to put this in the middle of your thread range and then find out you need to thread it out a little ways. And the big thing is you want thread engagement, right? So this sleeve is threaded all the way through. So right now we currently have over 1 inch of thread. If we put it in the middle, and then we need to thread it out a little bit more. You know, now we're down less than half an inch or so of thread. So you really want to try to get this as close as you can, but it's the reason we do this with threaded ends, so that we can make our fine adjustments. Okay, so we'll go ahead and test fit this one more time before we finally weld it. Not that I can really add more tube back on, but you can always cut more off. And I decided to cut it just a touch shorter, but that looks perfect. I mean, our bolt hole lined up there. So I'll go ahead and pull it all back out again and finish weld our bushing on. Okay, after what seemed like eternity, now we have a tube that we can put on here for our crossmember brace here. So I got to figure out what the best way to do this is going to be. Obviously, I've already kind of cut this and committed to this. And what I mean by that is that this crossmember is like two separate pieces of metal put together by GM and then welded at the seam. And where the seam is, the lower is actually taller or sticks out further than the upper half. So I think what I'm gonna have to do is try to cut the tube to the length of the upper half and then put like a 1/4 of an inch notch in it so that it fits here on the bottom side. I do need to make sure that it's going to clear the rear end. So I can't have it too far to the center that it, possibly contacts the upper control arm mount here. But I also want to keep it as far centered as possible so we have an adequate amount of space to run our dual exhaust through, as well as hopefully if FedEx delivers sometime today, we'll have shocks that are going to have to go back in, probably in here, as close to the control arm mounts and the frame as possible. But to keep progress moving, we're going to go ahead and get this installed. So we'll go ahead and I'll get a measurement to here. I'll lob this excess inch and a half off, whatever, in the bandsaw. And then I I might have to just use a cutoff wheel or whatever to put my notch in there. And while I'm doing that, we'll get a wire wheel and we'll get the rest of this cross member cleaned off here, so all our undercoating's off and we can get a good accurate measurement. Okay, so we're still just a touch big, but that's good. I can work with that. So now I'll start to cut my notch in here. And then we'll do the last little bit of sanding with a flap disc just to make sure it's a perfect fit and drop straight in place. Okay, so something like that, it's going to work great. As you can see there, we've got a little bit of a notch going on to fit on our, our seam between the two pieces, and it fits in there nice and tight. Got a nice radius over there. The hole saw did a good job. So I just got done saying that'll work. But I think I'm going to move the cross member over to the outside of the frame a little bit more. Just, I would hate to have that touch. Actually, I probably should throw my track bar in first, just to make sure that my axle's centered, right? And we got our 6 3/8. We know we're centered. And let's see how much room we have between the bolt head here and our brace. Yeah, see, we only have 3/4 of an inch, so I'm going to scooch this over just a touch more. Probably go a whole 1/4 inch. And yeah, now we've got an inch of clearance between our bracket, and I like that a lot better. So we're 17 to the outside of the frame, and 17. So that looks nice and square. Okay, so I'm going to put a level on it real quick, double check that everything's good, and then I'll burn that in place as well. Now, in case you're wondering through this whole thing, we're using a Miller 211, Miller-matic, whatever. We are using 30 thousandths wire, and we've been using the auto set feature. My brother doesn't seem to like it, but I think it does a pretty good job of figuring out what the wire speed is. Most everything was done on like the high side of the 3/16 setting, so the welder turned up to about 8 or so on your dial. This one I've got it turned down to 6 because even though this is 1/8 wall and this might be 180, I don't remember, this tube might be 3/16, but it's a lot thinner right here on these edges where the hole saw went through, and I don't want to have to worry about it burning through there a ton. Plus, the way I've kind of ground a little bit of a bevel on here, we're now a little thinner than 1/8 inch. And this bracket's only about 1/8 inch or so, so I'd rather have to make another pass than risk blowing holes in it. Okay, all is not lost. FedEx finally delivered, 2 days late. It's actually not that bad for them around here. I know different parts of the country FedEx might be good, and UPS and the post office sucks, but it's not the case here. So, our fresh box from Summit with our Ride-Tech coilovers. So, I figure we'll do a little unboxing. Check these out. Look at that. Okay, so we've got our coilover shocks themselves. This here should be our spring retainer. Yep, so this is our spring seats, retainers, the misalignment spacers for the shocks, the Delrin washers. Those are real important. I think some shocks you can actually get a Torrington bearing on them. That would probably be even more ideal, only because sometimes cranking up the preload is kind of a pain in the butt when you've got 150 pound per inch spring rate. These actually won't be that bad. It's the fronts that they're awful, really. But these look pretty good, so I might hold off on putting the springs on them. And the reason I'm saying that is because we've been doing everything with the truck at ride height, so it's gonna be difficult to have everything at ride height if I have the springs on. Whereas the shock, I'm actually kind of surprised these are extended and they weren't strapped. A lot of times shocks are delivered with a plastic binding on them or metal binding to kind of hold them down, but I very well may try to strap these compressed a little bit just to try to get a better idea on the length of them for our ride height. But for right now, I'll go ahead and I'll get the misalignment spacers installed, and I don't know, maybe I'll just lift the whole truck up a little bit. I don't know, we'll see. Really, ideally, you should do this without the springs on it, so that you can cycle the travel and make sure that you've got, adequate, no binding and adequate travel and clearances and stuff without the springs on it. Obviously, it's a lot more difficult to do once the springs are on, but at the same time, springs are a lot larger in diameter than the shock itself, so you want to make sure that you've got enough clearance around the shock. So I don't know, we'll play this by ear, but for right now I'll at least go get the misalignment spacers on them and get them set up and mocked up in the truck. Okay, so looking at our shock here, we have, I'll just say approximately 4.5 inches to the bump stop. All right, I guess it's actually more like 4 3/4. So, to figure out where our ride height's going to be, I would rather have a little more up travel than droop in this case. I guess for building an off-road rig, maybe it could be the other way around. But, so I think what I'm going to try to do is I'm going to set it up so we have 2 inches of droop, 2 3/4 inches of up travel. So I don't want to mess with the height of the truck. Pretty happy with where that's sitting, but our jack stands are up a notch here, and so what I think I'm going to do is I'm going to jack the axle up. I'll measure from, say, the caliper, the rotor, or whatever to the floor, and then just lower the axle 2 inches, and then that should get us at full droop. And then at that point we can set our shocks up. I got looking at trying to figure out if I could bind them together, and all my ratchet straps are kind of wide. So I'm thinking as they wrap around the end of the shock, it's going to kind of conflict with my shock mounts. So I got that one somewhat assembled, so I'll get this one done and get the axle drooped, and we'll figure out our shock mounts. Okay, so I've gone ahead and dropped the axle 2 inches. Fortunately, all I was able to do was just take the upper part out of the jack stand, and that happened to work out to exactly 2 inches. So from what I can figure, now the axle is at full droop. So it'll be easier to set up our shocks now and just try to get a rough idea about what we need for shock mounts. So what I'm thinking here is probably one of the diagonal deals like this. Could do stud mount on the top, but probably something along these lines here. I mean, ideally, I think I want to keep this as straight up as possible because I don't know how. I guess I could look at the RideTech kit, but as you change the angle of your shock, you actually change the spring rate, and I guess you would, in theory, probably change the valving of it too. The more straight up it is, the softer the spring would work because it's taking the most load directly down. As you start to lean the shock, you actually would increase the spring rate of it. And like I said, I can imagine you probably would affect the valving too, because your shock wouldn't be traveling as much when it's canted on the side like that. Yeah, you would probably soften the valving, right? Because as the shock moves less, it's going to have a slower shaft speed. The slower shaft speed is going to move less oil through the valving stack. I would think it would soften the valving. So it's kind of, it would be the exact opposite of what you want, right? As your spring rate increases, you would want to increase your valving. So it's pretty important to make sure that everything's set up the way that the shock manufacturer kind of intends. So the other thing too is I'd really like to keep them as straight up as possible because I need to make sure we've got plenty of exhaust clearance through here. So something along these lines really isn't too bad. Again, you want to make sure we got adequate frame clearance here. Just as the axle does swing a little bit in its travel, the bushings do have some movement, right? So you don't want to make sure anything is real close to the frame where it could potentially touch. Also going to want to make sure we have access to our adjustment for our spanner. So we got a few different things to think about there. I do think I want to also get on the Barnes 4-wheel drive site and look at what's available as far as shock mounts goes too. That might help us decide. Okay, so welcome back. We've got our shock brackets came in. Another round of order of from Barnes 4-wheel drive. Pretty much what we're going to do is we're going to burn these right to our 4-link bracket here. And then these uppers are radius, so they're going to fit nicely right here on our tube on the top. So I'm going to grab the welder, and I'm by myself in here today, so it's going to be a little more difficult to kind of hold everything in place, but I think what I'm going to do is I'm going to get the bottom tacked first because it's a little more defined as to where it's going to go, since I really need to have it centered on the bracket here. And I don't know if you can see, but if we start moving it around too much, it starts hanging off the edge, so it really pretty much has to go there. And then from that point, we'll get the top located and we'll be good to go. So let's get to welding. Again, on this side, it pretty much just has to fall in the same place. Again, it's really well located on the bottom as far as, you know, not sticking below the shock or the 4-link bracket and stuff. So that side is easy to do, and then the top, again, it locates pretty well on the tube. So I just measured over from the frame, 3.5 inches, so we can still have our same measurement side to side, and I like it. Okay, so now that we've got our tabs tacked on both sides, this side's probably a little more in the tack, but I'm going to go ahead and remove the shock and get the spring off so we can cycle the axle through its full stroke, make sure that there's no binding or anything here in the tabs, and then we'll disassemble the whole rear axle and get ready to fully weld everything. Also, one thing I wanted to add too was that if you are doing this and doing pretty much the exact same thing as us, 2.5 inch bolts would have been long enough. These 3s are a little longer than they need to be. And I may actually be able to just do this from here and not take the lower off too. Okay, so we got all our springs off now, and the shocks are holding the weight of the axle. So there's full droop. And let's go up and cycle the suspension and make sure everything's going to clear perfect. Okay, we now have the weight of the truck. So the big thing is I want to make sure I can still twist the shock a little bit. I mean, there's not a ton of movement, obviously, because it's the bearing is holding the weight of the truck, so it's pretty difficult to move. But if you can't move it, then there's a good chance that your shock is actually touching somewhere, which I believe is what we got going on here on the driver's side. Let's check it out. Okay, so you can see the slight mark right here in the shock body where it actually touched the side of our bracket here, or our tab. So that is going to be a little bit of an issue, but I don't think it's too big of a deal right now. I think what I'm going to do at this point is go ahead and remove the shocks, disassemble everything, and while we're here, I'm going to take a Sharpie and I'm going to put a little mark right here, reminding me to grind that area out. And I can just take a flap disc from the bottom and get that doctored up just so we got a little bit more clearance. But other than that, I think everything looks pretty good. So I think at this point it's time to start tearing the rear end apart. Okay, one more final thing I wanted to touch on here before I gotta leave the shop for a bit is this bracket. I think I touched on it earlier. Was the holes in it were 5/8 of an inch, and everything that we're using for our bushing ends and stuff are 1/2 inch. So Barnes 4-wheel drive and Ballistic Fab, Rough Stuff Specialties, I mean all your off-road part supply place offer these. They call them fix-it washers. So what this does is, say you had a bolt that was loose, you didn't realize it, and you kind of wallowed out the hole. You could drill it up to the next size. So in this case, it's 3/4 of an inch, and weld this guy in place around the outside, and it allows you to kind of save your hole without having to try to weld up, you know, your thin 1/4 inch plate or whatever. So so I'm gonna install these in here. I just got the holes drilled to 3/4. You know, the other thing too with these is they work really good as a reinforcement, because now you have an extra 3/16 of an inch here, plus your weld area all around here. So these are kind of a handy tool. So I'm going to just reinstall the bolt in here quick to hold everything tight, just so I don't have to try to hold everything while I'm while I'm welding them in place. And then I'm gonna go home and get some dinner.